Hello everyone, welcome you all to today's class, and today's class is on straight line. Okay, and in earlier classes on this topic we already have studied the basics. I mean slope of the line, then we have studied angle between two lines, right? And the condition for two lines to be parallel and perpendicular. Okay, so in today's class we will be studying equations of straight line in various forms. Okay, so let's begin the class. So coming back to the class, so it is equation or equations of straight line in various forms, and out of which we will be discussing on point slope form and 2 point form today. Okay, and before we go to this point slope form and 2 point form, so let me tell you, whenever you visualize any line, yeah, if you think about any straight line, so you may be thinking like the line may be like this horizontal, it may be like no coincident with x-axis or parallel to x-axis. The line may be like this, it means it may be parallel to y-axis or coincident with y-axis. Okay, or the line may be like this, it is neither horizontal nor vertical. Okay, so we will be discussing all three cases. So first of all, when I take equation of a line parallel to x-axis, now from figure 1 and 2, what you can observe, so in this case, first case, the line parallel to x-axis. So what is the basic characteristic of a line which is parallel to x-axis? As you can observe, the vertical distance is constant. See, whenever we take any two lines, I mean any two parallel lines, so this distance is, it remains same everywhere, right? So similar thing is happening here. So the line is parallel to x-axis. So distance of this line, everywhere the distance of this line from x-axis is constant. It means whenever you take any point on the line, for every point, for each and every point, you see y coordinate is remaining same. So it means what we can observe from this characteristic, equation of a line parallel to x-axis means the equation is, I can write here, equation is y equal to constant. So if the constant is positive, you can have the line above x-axis. If the constant is negative, the line will be lying below x-axis. For example, if I write here y equal to 3, so that means this line is parallel to x-axis at a distance 3 units from x-axis, and the position of the line is above x-axis, right? So like this figure 1, the line I have taken, and if the line is, suppose for example y equal to -2, so here the line is parallel to x-axis at a distance 2 units from it, and the position of the line is below x-axis, like figure 2. Okay, so it means the line may be lying above x-axis, below x-axis, but what will happen if the line is coincident with x-axis? It means if a line is coincident with x-axis, then I mean the, it will be like this. So it will be x-axis, you can say x-axis itself. Okay, the line is coincident with x-axis. So it means the distance of the line from x-axis will be 0. So we can say y equal to 0. So equation of the line will be y equal to 0, right? It means we also can take equation of x-axis is y equal to 0. Okay, so maybe we can say equation of x-axis is y equal to 0. And also any point on x-axis, I mean that point will have y coordinate 0. You know that. Now second case is equation of a line parallel to y-axis. So here you can see the line parallel to y-axis. It means it is perpendicular to x-axis. It means the line is vertical line. So here you can see in the figure. I can take it as figure 3 and figure 4. So in fourth figure you see this line is parallel to y-axis. And I have taken certain points on the line. Here like you see 1 minus 1, 1 0, 1 1, 1 2 like this. So the general characteristic here is for every point you see x coordinate remains same, right? 1 minus 1, 1 0, 1 1, 1 2 like this. So it means, so this distance, I mean horizontal distance is same everywhere because the line is parallel to y-axis. And in this case also this is a0. So wherever you take the point on the line, for each and every point, x coordinate will be a. So it means for this, the general characteristic of equation of a line parallel to y-axis will be what? Equation will be x equal to constant. And if this constant is positive, the line will lie to the right of y-axis. And if the constant is negative, the line will lie to the left side of y-axis. So it means if I write here x equal to minus 2, okay, so x equal to minus 2 means, so here I have x-axis, y-axis, I can take like this, y dash and x dash. So suppose you have minus 1, this is minus 2. So when I say x equal to minus 2, so y can take any value. So it means y will vary and x will be constant. So this line. So x equal to minus 2. So the line is parallel to y-axis at a distance 2 units from it, lying to the left of it. Okay, so this is the case. And if I just bring this line coinciding with this, or this line coinciding with y-axis, if the line coincides with y-axis, or it becomes y-axis itself, then this distance will be 0, right? This distance here it is x equal to 1, right? But if the line is coincident with y-axis, it will be closer to y-axis. So it means what? Your x equal to 0. Okay, so what can you conclude here? Your conclusion can be like this: equation of y-axis is x equal to 0. Okay, similarly equation of x-axis will be y equal to 0. So it means in these two cases we have studied, if you take x-axis, equation of x-axis is y equal to 0. Equation of y-axis is x equal to 0. If the line is parallel to x-axis, equation is y equal to constant. And if the line is parallel to y-axis, its equation will be x equal to constant. Is it clear? So you can visualize this from these figures. Now next, if the line is neither horizontal nor vertical, so it means if the line, the position of the line is like this, it makes, I mean an angle with x-axis which is neither 0 nor 90 degree nor 180 degree. Okay, so let's consider these cases. Okay, so here we can discuss two forms. So basically to get the equation of the line, we can think of these two forms in today's class. One is point slope form. In point slope form, so what will be given to us? We will be given the line passes through a given point x1, y1 and slope of the line is m. So it means point will be given, slope will be given. So here you say, yeah, so now we can see here, suppose we have, yeah, so like, let me take it as A, x1, y1. Okay, the line passes through the given point A, x1, y1 and slope of the line is m. Now let me take pxy, any point on the line. Okay, so let me write it here. Let pxy be an arbitrary point, be an arbitrary point on the line. So let me A. Okay, so arbitrary point on the line. So we can say it means basically the variable point, because whenever you form the equation without variable, you won't be able to get the equation, because every equation contains a variable point. Okay, so little later I will tell you why it is like this. So let AXY be an arbitrary point, I mean any point or variable point on the line. So given point is x1, y1. Okay, this is P, this is A. Okay, this is A and this point is P. So in most of the cases, let's take like this, Pxy, any point, variable point, moving point, so arbitrary point. Now, if I look at the line here, so it means I am able to see 2 points on the line. One is x1, y1, then other point is which is variable point xy. So it means slope of the line will be what? Slope of AP is, so as per the definition, it should be like y minus y1 divided by x minus x1. Okay, if I look at the line only. But if I go back to the condition given to us, slope of the line is m. So that means y minus y1 by x minus x1 equal to m. Right? So it implies y minus y1 equal to m into x minus x1. Okay, so this is the equation of the line. This is the equation of the line in point slope form. So the best way to use, I mean apply this formula, if you think when can we apply this formula? Point slope, point given, slope given. So there is no confusion, right? Whenever you will be given point and slope, it means line passes through a given point and slope of the line is given. And even if not, sometimes it may happen you will be given line passes through a given point, right? And instead of slope, you will be given inclination of the line. I mean the line makes an angle, for example, 75 degree with x-axis. Okay, if the line makes an angle 75 degree with positive direction of x-axis, slope can be easily found out. And tan 75 equal to slope of the line. So you can do it easily. Means indirectly you are given slope, right? So point given, slope given. So in that case, we have to apply point slope form. Okay, so let me just take one question. Yeah, so find equation of the line which passes through minus 4, 3 and having slope 2. So passing through minus 4, 3 means this is the given point x1, y1. And having slope 2 means we are given m equal to 2. Okay, so let Pxy be any point on the line. So even if you do not write this, if you want to just directly apply the formula also, it is fine. Okay, so Pxy be any point on the line. So here equation of the line would be what? Point given, slope given. So no confusion. So y minus y1 equal to m into x minus x1. It means y minus 3 equal to m is 2, x minus x1 means x plus 4. So we are getting what? Y minus 3 equal to 2x plus 8, or you can say 2x minus y plus 11 equal to 0. This is the required solution. Okay, yeah, required equation of the line. Yeah, equation of the required line. Is it clear? Very easy. Okay, next 2.4. So here the condition will be the line passes through two given points. Okay, so the condition will be the line passes through two given points. Let me take it as ax1 y1 and bx2 y2. Line passes through two given points. Then we have to find equation of the line. So again, without variable, we cannot have the equation. So let us say, suppose, let me take the point here, maybe P, X, Y be any point on the line, right? So it means here what we can do, A, B, P are collinear, right? So it means slope of AP equal to slope of AB. Okay, because ABP, yeah, AB and AP are coincident lines, right? They are part of the same line. The slope of AP would be what? Y minus y1 by x minus x1 equal to slope of AB is y2 minus y1 by x2 minus x1. Okay, so it means this can be taken as equation of the line in 2-point form. Or you may write here y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So the equation of the line can be taken like this or can be taken like this. And let me tell you a very simple way also. If I write here y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1, and if you link this with point slope form, is it same as that? Just look at this. So slope of the line will be what? Slope of the line is y2 minus y1 by x2 minus x1. Okay, now passing through x1 y1. So it means since we are not given any angle, I mean inclination, and also we are not given slope of the line directly, but we are given the line passes through two given points. So from that information, we can find slope of the line. Then we are applying here y minus y1 equal to m into x minus x1. Okay, so you can take any of the three. Okay, equation of the line in 2-point form. So whichever form is convenient to you, you can remember easily, but the logic in all the cases is same. Okay, so now I would prefer this one you must use, otherwise anything is fine. Okay, so find first slope, then you can apply the formula. Now let's take one question. find equation of the line which passes through the points 2, -2 and 3, 1. Means the line passes through two given points. Let me take it as x1, y1 and x2, y2. Okay. Now, if I just want to solve it in a very simple way, slope of the line would be what? Slope m equal to y2 minus y1 by x2 minus x1. That is 1 minus of -2. Okay. 3 minus 2. Means you are getting here slope is 3. Okay. Equation of the line is y minus y1 equal to m into x minus x1. Simple. So it means y plus 2 equal to m is 3 here. 3 into x minus x1. Right. It means we are getting y plus 2 equal to 3x minus 6. Or you can say 3x minus y minus 8 equal to 0. Okay, 0 equal to 3x minus y minus 8, or you can write like this. Okay, so this is equation of the required line. Okay, so basically, so these two forms, so we had planned to study today, so we just finished. And before winding up the class, I just want to introduce one good concept like locus of a point. So now whenever we say locus of a point, what does it mean? So what I have written here, the path traced by a point by following certain geometrical conditions. Okay, the path traced by a point by following certain geometrical conditions. Okay, so have you seen the rocket when, so when you don't, you see the like this, some spots like this, no, white spots in the sky. So you think, okay, now like no, the rocket has passed. Okay, so it means the rocket leaves the stress of its movement. Similarly, whenever I take, suppose for example, y equal to 2x plus 1. Okay, now y equal to 2x plus 1 is a condition. Condition means it is again geometrical condition. Or we can say relation between x and y. Or you can say y is a function of x. So whenever you write x, y, you take some points. For example, you take x equal to 0, you get y1, x1, y3. So like this, if you take certain points, 2, 5 like this, and you find, if I plot these points 0, 1, so maybe here 0, 1, okay, 1, 3, 1, 3 maybe here, okay, this point is 1, 3, 2, 5, 2, then I can take here, maybe here it is 2, 5. If I join these points, no, it traces a path, and that path looks like a straight line. It means locus of the point xy, okay, here, if I take pxy, the relationship between x and y is given by y equal to 2x plus 1. So the path traced by this point is a straight line. Okay, it means locus of the point is a straight line. I mean locus of this point which is related by like this, which follows the geometric condition y equal to 2x plus 1 is a straight line. Similarly, if I take some other points, you will be studying later on. If I write here x square plus y square equal to 16. Now, if I take various points and I will find the path traced by the point xy, okay, the path traced by the point xy, y following this condition will give us a circle with center at 0, 0, radius 4 units. Yeah, if I write here y square equal to 4x. Now, if I take various points, pxy, okay, and xy are related by this relation, by this condition. Now I will find the path traced by the point following this geometry condition will be, I will be getting like this. Okay, so these are basically, I have taken three cases. One is straight line, here is parabola, and here is circle. So in all the cases, so these curves are paths traced by the points by following certain geometrical conditions. It means locus, we call locus of this point in this case is a parabola. Locus of this point, I mean pxy, okay, so in this case is a straight line, and in case of x square plus y square equal to 16, when the point follows the geometrical condition x square plus y square equal to 16, we get a circle with center at 0, 0, radius 4 units. Okay, so it means, so for a layman's language, how do we define, how can we say locus? Okay, so if somebody is not a mathematics person, and if somebody asks you what is locus, so very simply you can say locus is basically what? A curve. Okay, locus is basically a curve, a graph of a function. Okay, and whenever we say a function, and in case of function, dependent and independent variables, they are related by a condition. Okay, they are, I mean, they're associated by a geometrical condition like y equal to 2x plus 1, or y square equal to 4x, or x square plus y square equal to 16. Is it clear? So locus means, simply said, it is graph, it is the curve. And we get the curve. Curve or function means what? Obviously, without any condition, we cannot draw it. Okay, to draw a graph of a function, you need some conditions. That condition is function. The condition is basically geometrical, condition we mean here. Okay, so that's why whenever you get any, you can say any curve, any equation, the geometrical condition is basically, you can say, this is equation. Okay, equation is basically what? Relationship between x and y, dependent and independent variable. Okay, and path traced by this means that path traced by the point, that is basically graph of the function. Okay, graph, or you can say this is curve, graph of the function, or you can say curve, right? So locus of this is. So that's why for any equation, whenever you take any equation, the variable point has to come. So unless the variable point will be there, unless the path is traced, you cannot have the equation. Okay, so locus of the point is very, very important in all the, concepts in coordinate geometry. Because unless the path is traced, you won't be able to know parabola, circle, straight line, ellipse. So we will not have any terms then if we do not know locus. Okay, so in every topic, maybe like in case of parabola, ellipse, circle, so then, you will be coming across the term locus. So I thought maybe I will introduce the term here. Locus of the point means what? Okay, so that locus term will not be new to you, right? So locus is basically path traced by a point by following certain geometrical conditions. Okay, so thank you so much. And today's class we have to wind up here. And in next class we will be coming with straight line, again equation of the straight line with some more forms, and of course we will be taking some questions. Okay, thank you so much.